Hey guys, so here I am in Berlin, finally made it. And so I know you guys are at school right now, and some of you are still trying to figure out how the best way to um, approach these scientific notation problems. And I watched the Khan Academy video, and I didn't think it was very good, so I'm decided to make a maybe a clearer, more laid out version for you. So the best way I've thought so far of categorizing these problems is to put them into four categories, where you either have what you're either talking about a big number, maybe is in the thousands or millions, or you're dealing with a small number that's more like a really tiny, skinny fraction with a decimal in it and a bunch of zeros after it. So looking at either one of these two options, you're either moving from scientific to regular notation or standard notation, or you're moving from the standard notation back to scientific notation. So depending on what you're working with, you should know which way to move the decimal point to get what you want. So whenever we see a positive exponent up here on 10, when we're talking about scientific notation, we always know that that's going to wind up being a big number because we're going to be scooting this zero back a few spaces depending on how many numbers are up here. So let's say we have 4.5 times 10 to the 5. Well, we take this decimal point, right, and we place it here on our standard number and we move it back 5 spaces. 1, 2, 3, 4, 5. That's going to make this number big, so it turns out to be 450,000. So you can always tell which way your decimal needs to go because you can tell whether or not you need to have a big number or a little number. So when you're working the other way around, maybe it's a little bit easier because you always know where the decimal is going. So if we say we need to put 5 million, let's say we know that number in words, 5 million, that's this amount of zeros here. We want to write it in standard notation or scientific notation, so we just take it and move the decimal up as many spaces as we need to get it behind the first term. Remember, in scientific notation, we're always putting this decimal behind the first number, and that's all we really care about. We want to know what's the best way to write this. So whatever that gives us for our number up here on top of 10, we don't really care. We just want it in this format so that then we'll know how many spaces we need to move it up or down. So like in 5 million, we start where if we're going from regular to scientific, we're starting in regular notation. We're starting in standard notation. When we're starting there, that means we put our decimal in the normal place that all normal standard numbers go. Right there at the ones place, right next to 0.0. So, there's nothing tricky about that. When we're going from standard to scientific, we always start at our regular point. These are commas, by the way, so I don't know if you can tell in that video. These are commas to tell you where the thousands place and where the millions place are. This is the decimal. It's down there at the bottom, at the beginning of the number. Okay, so that's for dealing with big numbers. Remember, whenever you see positive, you're going to want to have a bunch of places. You're going to have a big number, a bunch of money that you want to have. Okay, so let's think about that. Small numbers, on the other hand, we're thinking about them like they're fractions. Think about it. We are when we notice a negative exponent up here on the 10, we know that we're talking about a decimal and then a bunch of zeros after the decimal. So and maybe some of you don't have so much experience with those types of numbers, but just think of it as a very tiny fraction. If we multiply this times a number, it's going to reduce the size of that number. It's going to make it so that you just have a little tiny piece in the end. Okay, so this is much, much smaller than 1. It's bigger than 0, right? It's not negative. Okay, so if we were thinking of things in a number line, let's say this is 2, this is 1, and this is 0, and this is -1, then numbers with positive exponents will be way up the charts up here in the big numbers area. And then when we're dealing with these numbers with negative exponents in their scientific notation, we're actually crunching all of them down into here between 1 and 0. They might stack up here close to the 1, or they might be way down here with lots of a decimal and lots of zeros into it. And that would be way down here closer to the 0. Not nothing, but low. All right, so again, we can think of it either way, whether we're going from regular to scientific or scientific to regular. Just gotta realize what you want your number to look like in the end. So if we want to put this, if we're given this number, we want to put it in scientific. Well, we know that. Remember, because anytime we're in standard notation, our decimal starts where it usually starts, where where all numbers are set up to start, right there between the ones place and the tenths place. Okay, so we start our decimal moving backwards because we want to get it to the beginning of that first term. We want to get it in between the numbers that are significant here. So we're sending this thing back to these numbers here that we know mean something. We don't want to have to write all these zeros. We want to write this in a different way so that we don't need to put a whole bunch of zeros here. So 1, 2, 3, 4, 5, 6. We're going back 6. So then we're going to write it like this. Then check and make sure that this makes sense. We got a negative exponent. Okay, we got a tiny little number. It's a tiny little fraction. All right, that makes sense. So when we're dealing with a scientific notation to start, we see that negative, then we're going to send this decimal in a direction that makes it look like a tiny fraction. Remember, don't send it this way. Don't send the fraction the wrong way. Don't send the decimal the wrong way. Because if we did this, if we made a mistake and said, okay, well, we got 3.6, so 1, 2, 3, 4. If we made a mistake and said this number turns into 36,000, and we're putting our decimal here, no, that's wrong. All right, we got to make sure we go in the right direction, and it's a little bit tricky when we're dealing with these negative exponents. So make sure you always think about what is your goal. When you have a negative exponent, you need a number that's got a decimal, a whole bunch of zeros. All right, remember, zeros on this side, the zeros that send it into the smaller zone of the numbers. Okay, we don't care, when we're dealing with these small, we don't care about the zeros on this side. You can put one of them there if you want. Sometimes that's the proper way to do it, and people, I don't really care about that much, but whatever. We got 0 point blah, blah, blah. So you can do that way. Just make sure you know what you're looking for each time. Okay, so if that's a little bit confusing to you, you can also think of it one more way. Why don't we think of 10 and their exponents, okay, the powers of 10. So when we raise up a number with an exponent, okay, when we put an exponent in here, we are doing something powerful to the number. So we are changing it by a big amount just by putting a small number up here. So, and this is the whole basis of how scientific notation works. Okay, think of this as the beginning. Think of this right here, the number 1. In scientific notation, or in terms of the powers of 10, the number 1 has a power of 10 that's 0. All right, when we are raising 10 to the power 0, it becomes 1. When we raise 10 to the power 1, it becomes itself 10. Any number does that. All right, any number does these things. They they always equal to 1 when you raise them up to the 0. So we can kind of think of this as another number line. And 10 to the power 0 could be the origin of our number line in this sort of logarithmic way. Sorry, I don't want to teach you these big words yet, but it's an exponential way of making a number line. Okay, because look, here's the 0, here's the origin, here's the -1 direction, here's the -2 direction. Hope you can see this. Okay, this is a -3 exponent. This is in the positive direction. It's a 1 exponent, 2 exponent, 3 exponent. So when you type these into the calculator, you can see what goes on if you don't believe me, so try it. And it works the same way when we were talking about this, moving the decimal up and down in scientific, and when we're moving in and out of the two different forms of writing numbers. Let's say we want to raise this 1 up a power. Well, okay, if we're raising 1 up a power, we're moving this decimal back. That's going to give us 10. If we want to raise it up another power, moving it back again. And you know that because you can type 10 squared in your calculator. You know that 10 squared is 100. You know that 10 times 10, or 10 times itself 2 times, because that's what that means, right? That's what exponents do. You know that that equals 100. Don't get yourself confused about it. You already know that. All right, so the one more way you can think about it. Check this out. At least on this positive side, you got a 2 exponent here. Well, check it out. You got a 1 and 2 zeros. You got a 1 exponent here. You got a 1 and 1 0 before the decimal, right? So we don't really care about the decimal. So up here at 10 to the 3, we've got 1 and 3 zeros. So every time you see power of 10 tack on another exponent, you're tacking on another 0. And it kind of works the same way down here in the negative zone too. We got 1 decimal place right here that goes along with -1. It's slightly different. We're not counting zeros yet. We're just actually counting the actual decimal place. You could count this one if you really want. If you want that to be a 0. Okay, so that way they see this. It kind of makes a little square. Think of it visually. Check that out. Isn't that cool? So if you got -1, you got a one decimal place. You got -2. That means you got 2 decimal places. -3, you got 3 decimal places, and on we go, forever and ever, in both directions if we want to. I mean, we can have some really big or really small numbers, and that is what scientific notation is all about. That's why it's important. Because as we continue to do more stuff with bigger numbers, you're going to have your calculator starting to give you really angry giant numbers, and they just become a pain in the butt if you want to sit there and write them, all the way out forever and ever. So this is just the way that we take the numbers that we have and write them in a clearer, quicker way. And once you guys get these fundamentals understood, I think you guys are going to be really good at it, and it's going to seem really easy, and it'll be really helpful. So let me know if you need some more help, and I'll see you soon.